name Qama comes from, it's an acronym for describing what it's about, and that is quick, approximate, mental arithmetic.
So on that note, I want to introduce Ilan Samson, who is with us from Qama, and who has brought us really just a tool that warms my math teacher's heart. Kirsten Winkler and I talked about it briefly on ENT the other day, and I'm going to turn this over to him and let him explain, but just start off by saying, wow, hooray, and it's about time. So Ilan, do please tell me about Qama. We now know what it stands for. Tell me a little more about it, and then we can see we're sharing the screen here, so I'd love to have a demo.
Sure. So first of all, thank you very much. I'm so happy to talk to you. Now, regarding Qama, there is one more comment about the name. Apart from being the acronym which it is, Qama also happens to be a word in Hebrew.
And what does it mean?
How much?
Oh, of course. Perfect. Perfect. I love it.
Right. Now, Christopher, Chris, can I suggest that maybe we start by, if I can demonstrate a few things about the calculator to you, because there's a word in English which I am getting more and more to hate, and that is the word about. Knowing about things rather than knowing it. Anyway, so you might find it interesting if I give a few demonstrate a few things that will be the quickest way to give a feel of what this is about, and also why, if I may say, it was a near impossible thing to bring about. The main, let's first of all just show one example. If we have something like 11.8, can you see what I'm doing?
Yes, absolutely.
Yeah, 11.8 times, say, root of 55. And when I click on the equal, you see there's no result, and that is no result shown, and that's the first feature. The result will be shown only if the user joins in the effort.
Excellent.
Now, like that's 55. Root of 55 must obviously lie between root of 49 and 64, so between 7 and 8. And something like that, 7 or 8 is 11.8, would probably be estimated quite simply as 10 times 9 or 10. Even if we put in something like 100, yes, yeah, it shows the result. If I after we finish one finishes a task, namely that one sees the task, the estimate, and the results. To do the next one need not clear anything. The next thing one keys in will clear the screen. And if we want to repeat the same calculation, we don't need to key it in again. We can use the repeat key. All the red markings require first clicking on the second. So if I do that, we get the thing back. And I just want to show what happens if one, say, gets it wrong. Say the student thinks it's 1,000. Then it just wipes it out and waits for a better estimate. Yes. People have often asked, why does it not give a hint if it is too big or too small? And the answer is that if we would do that, then students would very quickly simply try out, say if it says it's too much, would try out a smaller number and so on. And I insist that one does not learn reasoning by trial and error.
Exactly.
Right. Now, if we wanted to achieve, and I very much hope we will, the goal of this calculator being used routinely and exclusively everywhere, at least for extended periods, by school students, everyone else is welcome too, and so that they get into the habit of never calculating without using their head. For that to happen, there is a detail about this calculator which had to be addressed adequately, and that is how strict would it be regarding the estimates.
Right.
How close would the estimates have to be in order to show up the correct result? And the answer for that in the simplest way is to say that it would appear reasonable to the student. Now, what does that mean? That means that if they are forced to be very, very accurate, that would be tolerated only for very simple calculations. And on the other hand, the more difficult the calculations become, the more, the greater the tolerance need to be for the student to always feel that if they, for instance, had an estimate not accepted, and they later, one way or the other, find out what the correct answer is, that they don't feel, oh, I think my estimate should have been accepted. They would see and accept that that it should not have. Now, the problem is that there are infinitely many calculations, each with their respective difficulty, and therefore with their required respective tolerance level. And it therefore wasn't even clear from the start whether this thing could be satisfied at all, let alone with a program that would ultimately fit on this on a microchip that fits into a calculator. For instance, if, let us say, my task would have been to predict the spelling of the English language. Well, God couldn't do that, but let us say he could. Then there would be only a finite number of words to cater for. 120,000, 180, I don't know, something like that. But here we have infinitely many calculations, including composite calculations. So that is why this thing took 14 years to bring about. But I think you and hopefully everybody else will find that it actually works well, and I will give some examples. If we take, say, something trivially simple like that, this, as I hope you expect, will not tolerate anything other than the correct result. Yes?
Yes,
that
absolutely.
means if 47 it doesn't accept it, if we put in 49 it doesn't accept it, it accepts only the 48. By the way, I will digress for a moment and point out something which explains why even for this trivial example, the use of the Qama would be extremely beneficial, and that's the following. Everywhere in the world, I assume it's the same, that kids are essentially between induced and forced to memorize the multiplication table.
Yep, I think that's universal.
Yeah, and I suspected and found to be the case that if you take what I call a recent graduate of the times table, a child who has recently learned it, knows the results. If you ask him what is 6 times 8, and he says 48, and you authoritatively, not menacingly, but authoritatively say no, would they argue? And what I find is they might say it says on my table, but they would it's very rare that they would say, what do you mean no? It must be because of whatever. Yes?
Right.
Say that 6 times 10 is 60 and times 8 means 12 less or anything. Yes? Now, if they don't do that, if they just know the results and don't know where they come from, there's absolutely no point in knowing that.
Agreed.
All the results that one can find on Google. So one needs to attend the question of why are we teaching the kids to do that again. Now, I therefore always advocate to teachers and parents that they should not induce the children to memorize the table, but they should always, until such time that they remember the result anyway, should do it by performing the repeated addition. And therefore, if they would learn the multiplication using the Qama Calculator, they would never see the result before they go there themselves.
No, that makes perfect sense, right? Of course, if they need to understand, as you said, the repeated addition, or even alternate ways of getting from point A to point B. I can only imagine what would have happened if I'd had these in my hands while I was actually in the classroom teaching math. So this is very good stuff.
Thank you very much. I am very grateful, Chris, for the interview, and hopefully this will go well soon.
I certainly hope so. All right, take care.
Thank you very much.
Have a great afternoon.
Thank you.